just seen are a few cinematic shots of my first ever PC build, but it wasn't without its hurdles, hence the reason why I made a detailed breakdown of how I went about it and exactly why I made a custom PC. Now, for the past couple of weeks, I've been on a relentless streak of building. First, it was my living room and hallway. Then I dove into not one but two home office setups, and when I finally sat back to edit those videos feeling accomplished, my best model M1 Mac Mini, after years of peak performance, started to show signs of fatigue. For those who've edited on a struggling computer, you'll relate to this. Every time I try to open extensions on Premiere Pro, that dreaded wheel of death kept popping up. The project and effects on the timeline took forever to load, and when they finally did, the playback was just so junky, not to mention the painfully long export times it took on projects that used to take just a few minutes. Add to that the fact that I couldn't really do any serious gaming on my M1 Mac Mini, and that's what pushed me over the fence to get my custom PC. But I had one problem. I'm an absolute novice when it comes to building PCs. There I was caught in two minds, deliberating between getting a pre-built PC or going the DIY route, even though I was a complete novice at building PCs. Without reality hitting home, the easiest option would have been to buy a pre-built PC, but I decided to take the chance on myself and off to the races I went. Now, like most of the things I've built in my short DIY career, YouTube University is where I attend my classes, and for this particular one, I enrolled for classes with Professor Texos and LTT, carrying me through majority of the theory bit, while Mr. Matley gave me a lot of the insights on how to do it aesthetically, although I doubt I can replicate what he does, but I'll give it my best shot. After a few days of attending classes, my confidence rose to a good level and I was ready to dive knee deep into this PC build. My first task, picking the PC components. From the lessons I attended, I learned there's a bunch of sites where I could check the compatibility of my components, but I found PC Part Picker to be a lot more user friendly and easy to navigate. Now, since this PC was going to be used for both gaming and video editing, choosing the component was a bit of a balancing act, although I leaned more on my creative side, and here's how I went about it. For the graphics card, I chose the ASUS ProArt RTX 4080 Super, which would be more than capable of handling anything I throw at it. Speaking of handling, the GPU won't be able to do all those tasks on its own, and that's where its main partner in handling comes in. Enter the CPU, and the one I chose was the Intel Core i9-14900K. Now pump your brakes. I know you're about to kill me in the comments and be like, oh, why did you choose the Intel Core i9 with all its stability problems? Hear me out. Now, when I initially got the 14900K, my thought process at the time was, this is the latest and greatest, so it should be fine. But after pulling the trigger, I later found out that some users complained about it having stability issues that cause crashes and the dreaded blue screen, not to mention its tendency of being power hungry. Nonetheless, I decided to stick with it. With the two most expensive components out of the way, the motherboard followed next, and being a creator and casual gamer, the ASUS ProArt Z790 Creator Wi-Fi fit the build perfectly, and for a few good reasons. One is, its Intel Z790 chipset gives me the option to power the 12th, 13th and 14th gen Intel processors, with the option to overclock in the event I need some extra speed. Chances are that's exactly what I'll do. Now, given the fact that I'll be playing FPS games and editing graphic intense timelines, speed is definitely the name of the game, and DDR5 memory is the cheat code, if you know what I mean. Oh, and before I go any further, those massive files, you know, the 4K videos, the 3D renders I'm about to get into, the G-Skill Trident Z5 RAM sticks working in tandem with my CPU and GPU will make those tasks absolute child's play. When it comes to connectivity, the two Thunderbolt 4 ports on the motherboard working in tandem with Wi-Fi 6E and the 10 and 2.5 gig Ethernet connections will make transferring footage from my NAS and other external storage devices an absolute breeze. The one thing I have to ensure is sorting out the BIOS version because of compatibility, but that's something I'll sort out when I get to that stage. Moving along, having talked about the RAM in passing, as you saw earlier, the G.Skill Trident Z5 DDR5 6400 CL32 would be my RAM of choice. Now, just like other noobs, at first I had no idea what the DDR5 6400 CL32 meant, but after attending a few classes with the professors at LTT, I found out that DDR5 6400 meant the RAM sticks operated with a speed of 6400 megatransfers per second, and the CL32 meant that it would take 32 clock cycles for the module to access data after receiving a command. Moving along, putting that geeky stuff aside, the SSDs were next to come in. Since this is where the boot drive of my operating system would be stored, I needed to get something that would perform well while being reasonably priced. Enter the Samsung 990 Pro. From the videos I've watched, they are quite reliable, and the fact that they come with sequential read and write speeds of up to 7450 and 6900 megabytes per second respectively, a 5-year warranty and a DRAM cache chip, the two Samsung 990 Pros would be ideal for the tasks that lay in wait. Speaking of tasks that lie in wait, cooling would be the next one for my PC build, but before getting into that, I also got two SATA drives for extra storage. Back to cooling, this particular segment was a bit of a head scratcher. At first, I wanted to go the water-cooled route, but after seeing how expensive it can get and also the fact that this would be my first build, I didn't want to complicate things, so water cooling was pushed out of the frame and I was left with the option of an air cooler or an all-in-one cooler. Again, from the endless classes I attended at YouTube University, after seeing how well the ROG Ryujin 3 went with the Asus ProArt Z790 motherboard, that's what I opted for to use as my cooler. Coming with a 360mm radiator, this would perfectly fit in the case I plan to use, and you'll see that a little later in the video. With the CPU cooler out of the way, it was now time to get the power supply, and looking at the estimated wattage of all my components on PC Part Picker, I needed a power supply with a wattage output of not less than 850 watts, and as I learned in one of the lessons, one that was fully modular. With that in mind, after combing through loads of PSUs on the internet, I finally landed on the Asus ROG Strix Aura 1200 watt power supply, which is 80 plus gold certified, and if Professor Linus words are anything to go by, that's a good sign, but the most important bit was it's fully modular and designed for an ATX case. Speaking of which, it was time for me to pick the case, and when it came to the case, I had a few things to consider: personalization, airflow, ease of maintenance, and expansion. For personalization, I wanted something that would match the walnut aesthetic of my setup while still ticking the other boxes. Again, after combing through the internet for a hot minute, the Fractal North XL with tempered glass fit the build perfectly, and here's why. Its size was perfect for all my components, not to mention its amazing airflow, which will ensure cooling is on point. Secondly, the fact that it comes with a dust filter and removable side, top and front panels will ensure maintenance is a breeze. Last but not least, it comes with a decent amount of expansion slots, which is super important for a creator like me, as I'll be bumping up the storage further down the line. Finally, it allows for easier cable management thanks to its amazing layout. Talking of an amazing layout, the Fractal North XL is perfectly laid out for fans, and the ones I chose were the 120mm Lian Li Unifan SL V2s. I like them because of their clean design and the fact that they are daisy chainable and the RGB on them is minimal and addressable. Something worth mentioning though is the Ryujin 3 AIO comes with its own set of fans, but the good thing is they are also addressable, so I can get them to match with the rest of the lights. Another component which wasn't necessary but I decided to get was this vertical GPU mount from Fractal. For those wondering why, the Asus ProArt GPU is a work of art, and mounting it horizontally would hide the beautiful gold labeling on the GPU. With all my components picked, it was now time to get into the build. Getting into the construction bit, once again from my lessons at YouTube University, having a spacious working area with a mat, a Phillips head screwdriver, a microfiber cloth, and a place to hold the screws, in my case a sacrificial bowl, would suffice for the tools I needed. With my tools in hand, I went ahead and unboxed the motherboard, then placed it on its box. Now, since the ASUS ProArt Z790 comes with an LGA socket, aka a land grid array socket, the socket pins are on the motherboard, so I had to inspect and ensure the pins are not bent. Speaking of sockets, pin grid array, also known as PGA, is the other type of socket I learned about, and unlike the LGA socket, it has the pins on the CPU. With that knowledge in mind, after checking the socket pins, none of them were bent, so I went ahead and lifted the retention latch, unboxed my Intel Core i9-4900K, then using the triangle on one of the corners of the CPU, I lined it up in the correct orientation to make sure I don't bend the pins. From there, the retention mechanism and latch went down one after the other, and seeing the little plastic socket cover pop off was kind of satisfying. After that, I went ahead and installed the G-Skill Trident Z5 RAM sticks in DIMM slots A1 and B2. For those who might ask why 2 and 4, again, from my lessons with the professors at LTT, leaving the slot closest to the CPU empty improves the stability of the system at higher speeds. Speaking of higher speeds, the Samsung 990 Pros would help with that, but even though I'd watched countless videos on PC builds, I couldn't recall exactly what slots they'd go in, so I went for a refresher and came back with a rich vein of knowledge. I unscrewed the heatsink, then peeled off the protective film on the thermal pad and put it aside for the meantime. From there, I lined up the SSD into the slot, and once I couldn't see the pins, I secured the Q latch on the standoff, then put back the heatsink. After that, I repeated the same process for the second SSD. At that point, it was now time to move to the cooler. Like mentioned a little earlier, my cooler of choice was the ASUS ROG Ryujin 3. This was another tricky one, but thank God for YouTube University. Starting with the standoffs, I mounted them on the provided bracket, after which I joined the fans together, and this was super easy given the fact that they magnetically attach to each other. Once the fans were in place, I secured them on the radiator using the long radiator screws, then attached this cable on the side. For the newbies like me wondering what these cables are, this is their 4-pin PWM connector, and it's going to go in the CPU fan header that will allow the motherboard to control the speed and power of the fans. The other cable is a 3-pin 5V ARGB cable, and as the name suggests, it's going to power the lighting of the fans. When it comes to connection, it will be going on the RGB header on the motherboard. More on the wire connections a little later in the video. Next in line was the pump, and it needed to go on the CPU. I first removed the plastic casing on the pump, and since the pump comes with thermal paste already pre-applied, I didn't see the need to do it all over again. I then removed the screen which magnetically attaches to the pump, then carefully aligned it with the standoffs before securing it in place with the provided screws. At that point, everything was going well until I tried to secure the plastic casing with the screen. It was at that moment that I realized I'd secured the pump sideways. Good thing this was a fixable error. I unmounted the pump, after which I applied some thermal compound, then proceeded to secure the pump. Now, since I wasn't going to mount the radiator on the case just yet, I left it on the side in the meantime. Once the AIO was in, before putting it in the case, I had to do a pre-build test and make sure everything was working as required. For the pre-build test, I first mounted the GPU, then used the motherboard box flap to hold it in place. Following the manual, one by one, I pushed the PSU cables into their respective slots, and the result was an atrocious set of cables, but this is just for the pre-build test, so bear with me. From there, I connected the display to the graphics card and the keyboard to the motherboard, then came the time to power my PSU, and that's where I ran into a problem. I had no idea how to turn on the computer without a physical power button. This chewed my brains for a little bit, then I decided to go back to YouTube University, and after having another refresher from TechSource, apparently by use of a screwdriver you could get it cracking, so let me give that a shot. Now, for the novices like me, I know that's going to leave you scratching your heads, but here's how it works. On the front panel header of your motherboard, stick the screwdriver into pins 3 and 4 that are labeled power switch. Just like that, it powers on the computer, and once it was on, I checked and made sure my memory, fans, CPU and SSDs were detected. With those boxes ticked, I noticed the BIOS read 2023, which meant I needed to update it, but that's something I'll sort out a little later in the video. I then let it sit for a few minutes just to see how toasty it would get, and after about 10 or so minutes, things looked alright, so I decided to mount the motherboard in the case. For the case, the Fractal North XL was my pick, and I talked about the reasons why a little earlier in the video. Getting into the motherboard installation, I first removed the tempered glass and aluminium cover on the sides, then the top cover, after which the wooden front panel with a removable dust filter followed suit. After that, I got rid of the included case fans and left it open for the time being. From there, I switched my attention to the motherboard. Inside the case, I made sure it was properly aligned with the standoffs, then screwed it in. After that, I passed the front panel header cables through the cable management hole near the bottom of the case, then one after the other I slid them into their respective pins. Next in line was the audio cable going into the port labeled AFP, and this one gave me a hard time, but I eventually got it in. The USB-C cable went in next, followed by the USB 3. Now, from the tutorials I watched, the pins on this one are quite fragile, so I had to do it delicately to avoid bending the pins. With the storage out of the way, it was now time for the case fans to come in. For the fan layout, I wanted 3 intake fans at the front and 4 outtake fans, with one sitting at the back of the case and the remaining 3 on the radiator. With that plan in mind, first in line were the intake fans on the front panel, and for one particular reason. If I started with the AIO, I'd have no room to screw in the front panel fans. Talking of the AIO, before securing it, I had to temporarily remove the pump screen to make it easier for the radiator to go through. Now, since I'd mounted the radiator fans a little earlier, all I had to do was remove the plastic backing on the fans and into the case it went, but not before plugging in the CPU cables on top of the motherboard, since I knew it would be a hassle slotting them in once the radiator was secured. Once the radiator was in, I put back the pump screen, then gave it a wipe with a microfiber cloth to get rid of the smudges. At that point, the only thing remaining in the fan department was the rear outtake fan, and a few screw rotations later, it was in. With the fans and cooling out of the way, it was now time for the power supply to get into the case, but before that, I had to plug in all the cables. Once they were in, I mounted the PSU to the case, then came the part to plug the connectors into the motherboard. Starting with the 24-pin ATX connector, I passed it through the cable management channel next to the motherboard, then carefully plugged it in. Next in line would have been the CPU cable, but good thing I'd done it before to avoid fidgeting with the wires in that tiny space. After that, the PCI cable that goes into the graphics card was next, but since I had not mounted the GPU yet, I had to leave it hanging for the meantime while I started the GPU installation. Speaking of the GPU installation, I wanted to vertically mount the GPU to be able to display the ASUS Pro Art writing on the GPU fans, and the only way I could achieve that was with the help of a vertical GPU mount, and like mentioned earlier, the one I got was this one from Fractal. As for installation, since I learned the topmost slot is usually ideal because of its superior connectivity to the CPU, I removed all the slot covers and installed the vertical mount. I then plugged the vertical mount into the topmost slot, after which I lined up the GPU with a slot on the mount and pushed it in. With the GPU plugged in, it was now time to run power to it, and for the 1000th time, I ran the GPU cables to the cable management channel at the bottom of the case, then plugged it into the GPU. At that point, my PC build was more or less complete except for a few things, one of which was cable managing the cables at the back of the PC. Now, since I tried my best to ensure they remained reasonably organized during the build process, I didn't have much to do. Using a combo of zip ties and hook and loop ties, I carefully cable managed all the loose cables, and after about 30 or so minutes, it looked reasonable, and the best part is all the cables would be covered with the back panel. Speaking of panels, it was time for them to come back on the case, and one by one they resumed their original spots. With the mechanical bit of the build out of the way, it was now time to fire up the PC and address some of the issues I'd seen when I initially did the pre-build test. Luckily, there was nothing really concerning apart from the CPU fan detection error, which was an easy fix. After jumping into the BIOS, in the search bar I tapped CPU fan and a menu popped up. In the CPU fan speed sub menu, I selected ignore and did the same for the CPU fan speed low limit. For those wondering what that does, it bypasses the error message and it won't show up again on the boot screen. With the CPU fan sorted, I pressed escape then F10 to save the changes. From there, as taught by the LTT professors, I did a check on my CPU temperature, and after waiting for a few minutes, the motherboard temperature registered 37 degrees Celsius while the CPU temperature hit 43 degrees Celsius. From a quick Google search, anywhere between 30 to 45 degrees Celsius is the normal temperature for the CPU and GPU when idle, and that gave me the confidence to proceed to the next step. Speaking of which, RAM and storage were up next, and while the RAM sticks were registered, they were not running at the right speed. For context, on the BIOS it shows 5700 MHz while it's supposed to be clocking 6400 MHz. So once again, going by what I was taught, I enabled XMP, which is basically overclocking, and this would adjust the timing, frequency and overclocking of the RAM to what's on the spec list rather than the defaults. On the flip side, while this is good for performance, I later learned that it could cause stability issues, especially when done before the operating system is installed, so I backflipped on the changes and disabled it for the meantime while I figured out how to install Windows. For the Windows installation, being a novice, I came so close to spending $300 as you can see from my components list on PC Part Picker, but before I pulled the trigger, I stumbled upon a video from TechSource, and that's where I learned the smarter way. Downloading Windows directly from Microsoft, then getting an activation key for a fraction of the cost. With my newfound knowledge, it was just a matter of downloading the Windows 11 Pro installation file for my mini PC setup, then getting it into the empty 16GB USB stick. After a short while, it was ready and I simply plugged it into my new build and turned it on. Not long after, it booted into the Windows installation page, and after clicking next a few times, I got to where it asked me the location I wanted Windows installed. Now, since I wanted it in a separate partition from the rest of my applications, I wrote the size of the partition and it did the magic for me. Not long after, I got to the setup screen where it wanted me to connect to a network, but since that would start downloading updates and drivers, a trick I learned from another lesson at YouTube University was pressing Shift F10, which opens command prompt, then in command prompt inputting OOBE/bypass in a row in caps. Then when you press enter, the computer would restart, but now there would be an option to click on I don't have internet, and that's exactly what I did. From there, I basically said yes to location, find my device and diagnostic data, then for the rest of the privacy settings, I said no. After waiting for a few minutes, I was finally in, but I had to download the drivers for my graphics card from the ASUS motherboard site. I started with the LAN chipset, then finished with the audio drivers. From there, I installed them one by one, and once that was done, I finally had access to the internet and Armoury Crate automatically started downloading. After that, I went into the display settings to make sure it matched the 240Hz my monitor allows, and I was happy to find out it was already at 240Hz. At that point, it was time to update the BIOS. Now, since I got this compatibility warning on PC Part Picker, plus during the pre-build test, the BIOS version read 2023, updating the BIOS would be necessary to ensure smooth running of the computer. With that in mind, I searched for the ASUS ProArt Z790 Creator Wi-Fi BIOS update, then downloaded the BIOS update. After that, I started by formatting my USB, and while doing that, I ensured the file system was FAT32, after which I opened the zip file and extracted the files. From there, I double-clicked on the BIOS renamer tool, and when the command prompt popped up, I just pressed a random key on my keyboard and it automatically renamed the other file. After the name change, I dragged the other file into the USB stick, then instead of restarting it the normal way, I held down Shift and pressed restart. After that, my computer restarted into the BIOS and I went into the advanced mode. Then under tools, I clicked on ASUS EZ Flash 3 utility, after which I clicked on the PAZ790 cw.cap file and it opened up the new BIOS version 2801 and I clicked OK twice. Once the BIOS update was complete, I noticed I was still getting the CPU fan speed detection error even after I set everything to ignore. For those wondering the cause of the error message, it's because I plugged my CPU fan header into the AIO pump, so to rectify that, I turned off the computer and plugged it into the CPU fan header. Straight away the fans became quieter and the error message disappeared. Now if you remember a little earlier, I disabled XMP, but since I didn't want to leave any performance on the table, I enabled it once again, and when I jumped back into Windows, I activated it using a trick I got from TechSource. At that point, my PC build and the basic setup was pretty much complete, which was the perfect time to do some benchmarks. For the benchmarks, I wanted to start with gaming, and after downloading Steam, first up was Cyberpunk 2077 at max settings, and tell you what, I was impressed. I managed to clock around 63 FPS, and from what I've heard in the PC gaming world, Cyberpunk is quite GPU intensive, but my 4080 was handling it so well. When I lowered the resolution to 1920 by 1440p, which I assume is what most people use, I registered around 85 FPS, which is quite impressive. I also tested out Call of Duty Black Ops 6, and at low settings I was clocking around 113 FPS, which is up there, but since I'm playing on a super ultra wide, the image quality isn't the best. When I bumped the settings to max, I was registering around 100 FPS, which for a first person shooter game is top shelf stuff. Talking of top shelf stuff, Cinebench 2024 is right up there when it comes to stress testing your computer, and now that they have a test for the GPU, makes it even better. I ran the tests one after the other while Hardware Monitor Pro also ran in the background to monitor the temps, and when the Cinebench results came in, I was impressed. With the tests done, it was now time to integrate my new PC build with my Mac computer to make it a hybrid desk setup. For the hybrid desk integration, I wanted moving across Mac and Windows to be seamless, all the while using the same set of peripherals. Now, for those that might not know how to go about it, a Bluetooth keyboard and mouse like the MX Keys S combo would be the easiest way to go about it, but since I wanted to use my antique keyboard because it matched the aesthetics of my PC, Synergy is the application that would make that possible. I simply downloaded the software, then got into the server and put in my credentials. Speaking of server, that will be the computer your mouse and keyboard are plugged into, and for context, my new build is the server and my M1 Mac Mini is the client. Again, for those who can't get the hang of it, first download the app on your server computer and give it a name. After that, switch to your client computer and go through the same procedure. Once you're done, your client computer will pop up on the server computer, and all you need to do is align them according to the layout of your computers to allow the mouse cursor to seamlessly switch, otherwise it won't be possible. In my case, the server computer is on the right and my client computer is on the left. Just like that, my hybrid desk setup was up and running, which was the perfect time to give you guys some cool cinematic shots. Well, there you have it guys, I finally built my first custom PC for a total cost of 6,330 Australian dollars, which is about 3,950 American dollars. This PC will comfortably handle my gaming, creative and productivity needs without breaking a sweat, and I'm super excited to start using it as my daily driver. As always, I'll bring you guys each step of the way. My excitement aside, I hope you guys enjoyed this video and found it helpful. Once again, as always, don't forget to like, subscribe, share and click the notification bell to get notified whenever I post a new video. Speaking of which, here's a video detailing how I built the setup I will be using my custom PC in. Until then, people of the internet, I'm signing out. See you on the next one.